Hi everybody, we are going over end of module 2 review. And for the first one, it says we need to express the missing divisor using the power of 10. So you're going to have 10 and an exponent, and to use the place value chart to show basically how you got this exponent. So I've done the first one here. I went ahead and wrote 3,590 in the place value chart. And then, so that's our starting place. And then our ending place, I added in the place value chart as well. And the goal is to count how many places the digits shift to the right, right? When we divide, we shift to the right. And so you don't count the place where the 3 starts, but then you're gonna go ahead and count how many spots until you get to the 3 on this number on the bottom. So it goes 1, 2, 3, 4, which is how I got 10 to the 4th. You could also maybe number it so that you have just a quick view of how many places it shifted. Go ahead and do the next one. We'll add 2,580 on the place value chart, and then we end up at 2.58. And again, we're going to count the number of places we shift. So we've got 1, 2, 3 places, or 3, it's shifted 3 places to the right, and then our answer will be 10 to the 3rd, right? If it shifts 3 places, the exponent is 3, shifts 4 places, the exponent is 4. Now, looking at the next one, we are going to estimate the quotient by rounding the expression to relate to a 1-digit fact. We're finding friendly numbers here. You've got somewhere around 29 here, right, which is kind of close to 30. You've got 59 here. You could do a couple of different ones. I'll put a couple on here, but if you have others that have a similar quotient, that would be acceptable. So the first thing some of you are probably thinking maybe 300, so 30, let's say, 30 can be divided easily by 6, right? 60. So we could do 300 divided by 60, cancel our zeros. 30 divided by 6 is 5. Okay, next one here, we have 4,176 divided by 814. So we need to think of something around 41 divided by something like 8. And if, like me, you're thinking, oh yeah, we could do 40 divided by 8 as our basic fact, which means we would have 4,000 divided by 800, right? You need to make sure you account for all of the places there. Go ahead and cancel, cancel. Then you end up with your 40 divided by 8, which equals 5. Okay, explain your thinking in the spot below. Okay, so if we're looking for the basic fact, you're basically looking for a number that comes close to the original equation, but can be divided as a basic fact in your head. Okay, so as long as you're explaining, basically how you got to that basic fact, that would be perfect. Just need to make sure it's fairly close to the original problem. Okay, next page. Generate and solve another division problem with the same quotient and remainder as the problem below. Explain your strategy for creating the new problem. Okay, so we have 6 remainder 4. We need another division problem that ends up with 6 remainder 4. And we know that we need to pick a divisor that is greater than the remainder. So I'm going to write over here my strategy. So 1, okay, so we're going to choose a divisor that's greater than the remainder. Then we're going to use the multiply to check strategy. Okay, so then once we do the multiply to check strategy, that will give us our new dividend. So I'm going to go ahead and choose, let's say, the number 8. Okay, so I'm going to do 6 times 8, right? And if my new divisor is 8, then I'm going to be multiplying it by the quotient. So 6 times 8 is 48. And then we add the remainder plus 4, which gives us 52. And then this should become our new dividend. So we're going to go ahead and check that. So 52 will go in the house. I am going to divide by 8, which was my new divisor. 8 into 52 goes 6 times. 6 times 8 is 48. Subtract, that gives us 4. That gives us a remainder of 4. Okay, so our new equation will be 52 divided by 8 equals 6 remainder of 4. All right. Next one, Sarah says that 28 divided by 8 equals 52 divided by 16 because both end up at 3 remainder 4. And so we need to show her mistake using decimal division. The way we need to think about this, like I explained in class before, is even though these equations have the same answer of 3 remainder 4, decimal division is more precise. So I'm going to write that so that you remember. Basically, that means if when we do decimal division, we're going to get a more exact answer. Okay, so then the next step is to do both of these equations using decimal division. So first I'm going to do 28 divided by 8, and then I'm going to do 52 divided by 16. All right, so 8 into 28 goes 3 times, which is 24. Subtract, we get a 4. Now the next step, extend the roof, add a decimal, bring that decimal up to the roof, add a 0, bring that 0 down. And now we need to do 40 divided by 8, which we know is 5, and we have no remainder. So 28 divided by 8 is not just 3 remainder 4, but it's 3.5 or 3.5. All right, the next one, 16 into 52. If you need to, you can do some math off to the side. 16 times 3 is 48. That looks like that's going to work. So we'll go ahead and put a 3 up top. This is 48. Subtract, you get a 4. Now, next step, add the decimal, extend the roof, bring the decimal up, add a 0, bring down the 0. Okay, 40, 16 into 40 will go, what do you think? 1, 2, 3 times? No, 3 times, 2 times. 16 times 2 is 32. Subtract, that gives us 8. We can't have a remainder, so we need to bring down another 0. Okay, 16 into 80. I don't know, we can try 16 times 5 is 80. Perfect. So we can go ahead and put our 5 up here, and then we know 25 times 16 is 80, and we have no remainder, and our answer is 3.25. So for this one, you just needed to show both equations using decimal division so that we can see the more exact, precise answer. Okay, number 5. A rectangular playground has an area of 7,622 square meters. Okay, so a rectangular playground has an area of 7,622 meters squared. The width is 37 meters. And the length, that's a width, the length we don't know. But we also know area equals length times width, which means we could rearrange and we could take the area, divide by the width, and that will give us the length. So that's what we will do. We will do 7,622 divided by 37, and then that will give us the length. All right, so 37 into 76 will go 2 times, will give us 74. We will bring down the 2. Okay, sorry, I had a knock on the door. Okay, now we have 22. 37 goes into 22 0 times, right? So we need to make sure we account for that space. If you were to do the math, right, 0 times 37 is 0, subtract, you would still get 22. I'm not going to do that because it's still going to be 22. So then the next thing we're doing is bringing down another 2. And we need to figure out how many times 37 can go into 22. Well, I know that 37 is close to 40, and 222 is close, so this would be like 20, right? 40 goes into 25 times. I guess we could do it off to the side to see if it works. 185. 37 times 6, 18. 6. That divides evenly or multiplies perfectly. So 206 will be our length. Okay, so length equals 206 meters. And don't forget, when you have lots of space and a lot going on, you box your answer. So you know that's your answer, and I know that's your answer. All right, now the next one. This is very important because this is a long question. This will go on to the next page as well. So we need to make sure that we're doing the first part properly so that we don't, make it more difficult for the next parts, and then those will be incorrect. Okay, so a baker uses 7.25 pounds of flour daily. And then it says how many ounces, notice the difference here, how many ounces of flour will he use in 2 weeks? All right, you must show proper conversion process. Perfect. So first things first, I would convert 7.25 pounds to ounces, and then we can do the rest of it. So 7.25 pounds equals how many ounces? And don't forget, we're using the proper process here. Okay, so then that equals 7.25 times 1 pound. And then that's 7.25 times 1 pound is how many ounces? That would be 16 ounces. Okay, then we can do the math off to the side. 7.25 times 16, 33, 12, 15, 1, 3, 0, 10, 1, 6. Okay, now don't forget those decimal places. That is super important. Okay, so this will come out to 116 ounces. Okay, that's for each day. Okay, so per day, right? You want to label the different parts here so you remember what information is what. Then it says how many ounces of flour will he use in 2 weeks? Well, if we know that there's 116 ounces per day and 2 weeks has 14 days, then we're going to go ahead and multiply 116 times 14. Okay, no decimals, so that's 1,624 ounces in 2 weeks. And then we need to make sure we add our statement. Okay, so okay. Sometimes it does help to box your statement so I can find it. All right. Next page, we're going to have to refer back probably, but let's see. The baker's recipe for a loaf of bread calls for 14 ounces of flour, and he uses all of his flour to make loaves of bread. So if he does that, how many full loaves can he bake in 2 weeks? So 2 weeks worth of flour, which we know back here was 1,624. Okay, sometimes it helps to write it here so that you can remember. He uses all of this flour to make full loaves, and each loaf requires 14 ounces of flour. So if we do the division, 1,624 divided by 14, that will tell us how many loaves of bread he can bake in 2 weeks. Okay, so 14 into 16 goes one time. Subtract, bring down the 2. 14 into 22 is also 1. Okay, 84. Okay, 14 into 84, I don't know, maybe 6 times. 84. Okay, so 6 times 14 is 84. And we have 116 loaves of bread that he bakes in 2 weeks. Now, just a side note, okay, side note. Okay, so if he baked, let's say the answer was 116.7 loaves of bread, you need to remember it's asking how many full loaves. And we know that anything that comes after the decimal here is not a full 1. So it would end up being 116. Okay, so that's just a side note. Here, we're gonna go ahead and write our statement. The baker makes 116 full loaves of bread in 2 weeks. Okay. All right. Next one. It says the baker sends all of his bread to one store. And he packs boxes of the bread so he can put 15 loaves of bread in each box when he ships it out. And the question is asking what's the minimum number of boxes required to ship all the loaves that he baked in the 2 weeks. Okay, so again, we need to go back to the question before. Remember, if you've got any questions that are A, B, C, D, you might need to use information from the previous question. So on this one, we've got 116 loaves of bread. Okay, he can put 15 of loaves in each box. So if we divide by 15, it will tell us how many boxes we need. Okay, we can't go into 1 or 11. So 15 into 16 is probably going to go maybe 7 times. So let's try 15 times 7. It's 105. Okay, so we have 7, remainder 11, meaning we have 7 boxes and then 11 extra loaves. And it's asking, we want to ship all of the bread. Okay, it says he wants to ship all of the bread. So we can't just throw away those extra 11. Those still need to get packed in a box. So when it says what's the minimum, that means we need at least how many boxes? Well, we know we have 7 full boxes, and then we can fit 15 in a box, but we only have 11, so it'll be 7 boxes plus 1 more. So the baker needs a minimum of 8 boxes. Okay. All right. Next question. I think this is the last page. Yep. Okay, so moving on with the baker, we are continuing. The baker pays 75 cents per pound for sugar, and then $1.65 per pound for butter. It says write an expression that shows how much the baker will spend if he buys 6 pounds of butter and 20 pounds of sugar. One, we need to remember this is an expression. You do not need to solve, okay? Do not need to solve. But what we do need to show is how do we figure out the cost for 6 pounds of butter and 20 pounds of sugar? Now, pay attention. This is listed per, pounds of sugar first and then pounds for butter second. But then the question asks for pounds of butter first, then sugar. So don't get these switched around. Okay, so 6 pounds of butter, and it's $1.65 per pound. So we need to do 6 times 1.65 first. And again, we're just writing an equation. Then we need to add how much for the sugar. So we've got 20 pounds of sugar at 75 cents per pound. This is your expression. This is it. You don't need to solve, okay? I will even put a nice lovely box around it. All right, next one. Chocolate sprinkles cost as much per pound as sugar. Find 1/10 of the baker's total cost for 140 pounds of chocolate sprinkles. Now, this can get a little confusing when it says to find 1/10 of the baker's total cost. So really what that means is you're taking the baker's total and dividing it by 10. Okay, 140 pounds of chocolate sprinkles, which costs the same as sugar, which is 75 cents per pound. That means we need to do 140 pounds times 0.75. I kind of wrote that funky. Let me fix this so we've got a 0 in there. Okay. Then we go ahead and multiply. That's going to give us the total cost, and then we'll divide by 10. Don't forget the decimal places. So that's $105. Oops, sorry. There we go. Now you can see. So $105 for 140 pounds. And then we need to divide that by 10. Okay, we could do it on our place value chart. $105 divided by 10. Don't forget, we need to shift to the right when we're dividing, and we're just shifting one spot here, right? Because we're dividing by 10. So then our answer will end up, and I'm gonna put a 0 on the end there, $10.50. Okay, so 1/10 of the baker's cost don't forget the $sign comes before the number is $105. Okay, and then it says to explain the number of zeros using the place value chart. This is all you need to show. Okay, and that is the end of our first review. I hope you did a really good job, and you can use this video to help you with the second review if you need. Toodaloo.